Given an array of integer nums and an integer k, return the total number of subarrays whose sum equals to k. A subarray is a contiguous non-empty sequence of elements within an array. The numbers in the nums array can be negative and k can also be negative. Here is an example array and k is equal to 4. We need to find all subarrays whose sum equals to k. Let's start with the brute force approach. We generate all subarrays and compute their sums. Pointer I goes through each element of the array. For every I, we reset the subarray sum to 0 and expand another pointer j forward. We'll add elements as we go and increment the output count when the subarray sum equals k. This takes O of n squared time and O of 1 space. Instead of checking every subarray, what if we could skip all that and solve it in just one pass in linear time? Here's the fastest solution where we use a hash map to track prefix sums or running sums. We'll step through the array and at each index I, we'll calculate the running total of elements and call it running sum. In the hash map, we keep track of how many times running sum has appeared. We initialize the hash map with 0 mapped to 1 since running sum is 0 at the beginning. Let's walk through this example. Running sum becomes 6, store that with a count of 1. Then it becomes 4, we add that 2. And we have found our first subarray that adds up to 4, so we increase the output count to 1. Then it drops to 3, add that with count 1. Now we see 6 again, so we increase its count to 2. Then it jumps to 14, and finally the running sum is 10. At index 5, where the running sum is 10, let's subtract the target k from running sum, which results in 6. There are 2 occurrences of 6 in the hash map, meaning there are 2 running sums we found earlier in the array that added up to 6. This is the first running sum and this is the second one. If the total sum at index 5 is 10, then the subarrays that add up to 4 must lie between these earlier 6s and the current index. That means we have found 2 more subarrays that add up to 4 and we increase the output count to 3. The key is to subtract the target from the running total at every index and not just the last position. If that subtraction result exists in the hash map, we'll add its value to the total count. Let's now review the code. We create a hash map where the key is the running sum and the value is the count initialized with 0 to 1. We declare 2 variables, output count and running sum. Then we enumerate through the nums array and keep updating the running sum. If running sum minus k exists in the hash map, we increment the output count. Finally, we update the count of the current running sum in the hash map and at the end, we return the output count.